Have you ever wondered how companies analyze your behavior without exposing your personal details? It's a delicate balancing act, like trying to keep a recipe secret while still letting someone recreate the dish. Today, we're diving into a groundbreaking paper that tackles this exact challenge: how to protect privacy in business processes without losing the insights hidden in the data. Let's start with the basics. Information systems, like those tracking your online purchases or hospital visits, generate massive event logs. These logs are digital footprints, showing every step in a process. But here's the problem. They often contain sensitive info, your name, medical history, or shopping habits. Anonymizing this data is crucial, but here's the catch. Overzealous anonymization can erase the patterns that make the data valuable. Pause for emphasis. Imagine trying to reverse engineer a recipe from a log of cooking steps. If you randomly swap out ingredients, the final dish might not make sense. That's what happens when anonymization disrupts the structure of event logs. The more complex the process, the harder it is to preserve utility after anonymization. Shift to solution. This research proposes a clever workaround: event data partitioning. Think of it like breaking a recipe into smaller sections. Instead of anonymizing the entire log at once, they split it into sub-processes, like separating admissions from treatment in a hospital workflow. Each section is anonymized separately, preserving the overall structure while hiding sensitive details. Data-driven insight. Here's where it gets smart. By understanding the process structure, how steps in a workflow depend on each other, they can apply anonymization more precisely. For example, in a hospital log, they might anonymize patient names in the admissions section without scrambling the sequence of care steps. This approach keeps the data useful for analysis while protecting privacy. Experimental results. The team tested this using real-world data from healthcare, finance, and logistics. They found that partitioning before anonymization boosted the accuracy of process discovery tools, techniques that rebuild workflows from event logs. Specifically, methods relying on directly follows relationships, like step A always comes before step B, saw the biggest improvements. It's like making sure your recipe's instructions stay clear, even after hiding ingredient names. Technical depth. They compared two anonymization techniques: DF-Laplace, which adds random noise to data, and SaCoFa, a method that preserves structural patterns. When applied without partitioning, DF-Laplace sometimes distorted process models, while SaCoFa was more consistent. But when they partitioned first, both methods performed better. In one dataset, precision doubled from 0.3 to 0.8. This shows that partitioning acts as a buffer, protecting the data's signal before adding noise. Significance. Why does this matter? As privacy regulations tighten, organizations need smarter ways to protect data without crippling analytics. This research proves that thoughtful preprocessing, like partitioning, can bridge the gap between privacy and utility. It's a game changer for fields where understanding processes is critical, from healthcare to supply chains. Closing hook. Next time you see a privacy policy, remember, behind the scenes, researchers are working hard to keep your data safe and useful. Thanks for watching, stay curious, and let me know what other tech mysteries you'd like to explore. Music fades out.